For those that want to use a computer, laptop or server as music source, but want to use their DAX, AES, EBU or SPDIF input, a converter is needed. The MC 1.2 Plus can do this, and the reverse by the way. But how does it sound? I know the Mutec brand from almost 3 decades of working in the professional audio world. See my video Where I Came From. Their product range includes clock generators, clock distributors, reclockers, USB interfaces, format converters and sample rate converters. The MC 1.2 Plus reviewed here converts USB audio class 1 and 2 to AES EBU, SPDIF, AES3 ID and Toslink, but also AES EBU, SPDIF, AES3 ID and Toslink to USB audio class 2. The latter is usually not needed in a stereo setup. So where's the MC 1.2 Plus used in a stereo? When used to convert USB audio to AES EBU, SPDIF, AES3 ID and Toslink interfaces, combined called the AES3 family interfaces, a USB source is needed. In this case, a laptop running an application that can play music out bit perfect. That laptop will be connected to your network router over either a network cable or Wi-Fi. This gives access to internet radio and streaming services. If you have a computer or NAS holding music files, that might be accessed too. One of the AES3 family outputs is then connected to your digital to analog converter. That in turn is connected to an amplifier driving a set of loudspeakers or headphones. Instead of a laptop, you might use a network player or, for instance, a Raspberry Pi based streamer running software like Gentoo Player, Volumio, Diet Pi and so on. The MU 1.2 Plus is available in black and silver. The sturdy full metal housing measures 196 by 156 by 42 mm and weighs 1.12 kilos. On the front we see an LED indicating power status, a menu button and a select button. The menu button lets you select between the mode menu and input menu. Once in the mode menu, you can select between unidirectional or bidirectional operation. When the input menu is chosen, you can select USB, AES EBU, here named AES3, Toslink, here called SP-DIF optical, or SPDIF/AES3 ID. The following 4 rows of LEDs are there to report the status of the MC 1.2 Plus. There is an LED for signal lock on USB, one for signal lock on the other digital inputs, an indicator for when the mains power is used, one for when the DC power input is used, and both light up when the USB power is active. Then there is the status row for SPDIF that indicates original or first generation, non-PCM and DTS CD. The last 2 rows show the sampling frequency for USB and PCM separately. On the back we see the recessed power switch, the IC mains inlet, the 9 volts DC input for use with an external power supply, the USB B port that offers input and output, the AES EBU input, the AES3 ID/SPDIF input and the Toslink optical input. Then the outputs: AES EBU, AES3 ID, SPDIF and Toslink. The MC 1.2 Plus comes with 2 BNC to RCA adapters for those that want to use SPDIF. There also is a rarely used power plug that fits the Lumberg DC input. You need to solder it yourself to an external power supply. S-Booster offers a version of their 9 volts power supply with this connector. Inside all is mounted on a single circuit board. The power supply is a 5V peak switch mode module. The housekeeping is done by an Atmel microcontroller. The AES EBU input and output are galvanically decoupled by transformers. I also found the Burr-Brown DIX9211 digital audio interface transceiver and 3 buffers with drivers to output digital signals, and of course the Intel Cyclone 10 FPGA that does the important signal processing. If you want to know all about AES3 interfaces, I wish you luck. Not only the Audio Engineering Society, AES for short, but also the European Broadcasting Corporation, EBU, and the International Electrotechnical Commission, IEC, have loads of specifications, rejected standards and more recent standards and additions to the subject. When we look at the real world, things are a bit simpler. The mother of the AES3 family of interfaces is what in our world is named the AES EBU interface, but is also known as AES3/11. It uses 3-pole XLR connectors and 110 ohm twisted pair cable. For the broadcast world, there came the AES3ID interface that uses B and C connectors and coaxial 75 ohm cables. The electrical specifications are such that cabling for both digital and analog video can be used. AES3 can be transported over 1000 meters, while AES EBU is limited to 100 meters. What we know as SPDIF is basically identical to AES3ID, but normally uses RCA plugs on 75 ohm cabling and a lower voltage. SPDIF is specified up to 10 meters, although my experience is that you better keep it as short as possible to maintain audio quality. Toslink is fully identical to SPDIF, except it uses optical fiber as medium. Usually Toslink is simply a small chassis module directly connected to the electrical SPDIF connection. Between the professionally used AES EBU and AES3ID on one side and the SPDIF and Toslink on the other side, there's a difference in auxiliary data bits. This is a small number of bits called status bits that describe sample frequency, bit depth, preemphasis and some other properties. There's a bit that indicates professional use, which generation of the copy it is, and so on. In the consumer format there's the well-known copy prohibit bit. When high-end equipment started using AES EBU between CD transports and DACs, the question was what to do with the subcode, particularly the pro bit and the copy protection bit. That also had to do with digital recorders entering the consumer market. DAT, DCC, minidisc and hard disk. Therefore often the SPDIF data stream with consumer status bits was used with the electrical properties of AES EBU. Today no one cares about this anymore. The MC 1.2 Plus AES EBU output, called the AES3 on the MC 1.2 Plus, outputs a peak-to-peak voltage of 5.4 volts. The AES ID outputs 3.2 volts and the SPDIF 440 millivolts. Using the MC 1.2 Plus is rather straightforward. Connect the USB input to the USB output of your source. Then connect the AES EBU, SPDIF or Toslink to your DAC. The best choice is AES EBU, then SPDIF and last Toslink. Of course only use cables with the right specifications. A microphone cable is not optimal for AES EBU, nor is an RCA cable as used for analog audio for SPDIF. They might work, they often do, but will influence the sound quality. When all is connected, including the power, select unidirectional mode and USB as input. Any PCM signal up to 192 kHz 24-bit will be converted from USB to AES EBU and SPDIF. DSD will not work. As source I used a Raspberry Pi 3 that was running Rupee. It was powered by a cheap switch mode ball-ward power supply. The Pi was connected to the Zixel GS1900-10 HP switch over a Cat6 patch cable. The Ziggo business modem was also connected to the Zixel switch to provide internet access. The small green computer Sonic Transporter i7 CDR was also connected to the Zixel switch and provides room server, minim server and Audivana Studio Core music server programs. On the other side of the MC 1.2 Plus, the Holo Audio Cyan 2 DAC was connected over Network Acoustics Muon AES EBU cable. The outputs of the DAC were connected to the Air Acoustics AX520 amplifier over Grim Audio SQM XLR cables. It drives the PMC FAC12 signature loudspeakers on Stack Audio OVA 70 isolators and connected over AudioQuest Robinhood Zero loudspeaker cables. An iPad Pro 2 was used to control the music service. As you can see, the source for the MC 1.2 Plus is held as simple as possible, mimicking the average computer as source, including non-audio grade switch mode power supply. The MC 1.2 Plus itself was first powered using the internal power supply, and to see if an external audio grade power supply would improve the sound quality, I used the Ferrum Hipsus power supply set to 9 volts DC. This is a hybrid power supply using both switch mode and linear circuits. I would have loved to use a cheaper one. The Hipsus cost €1200, but this was the only power supply I have that does 9 volts. There is a third option to power the MC 1.2 Plus, and that is over the USB power line, since that would feed the usually dirty power and ground to the MC 1.2 Plus, so I didn't try that. You want the MC 1.2 Plus to convert all bits from one interface to the other or vice versa. Be assured that every bit is perfectly transferred and it is done in time too. Using tracks like Famous Blue Raincoat on the album with the same name by Jennifer Warnes, the original 1987 release, or sketches of Spain from the album Urk by the Nits, you can easily test sibilance control. Poor sibilance is greatly caused by jitter, but can also be caused by upsampling filters. The Cyan 2 DAC has no upsampling, therefore problems must come from either the Raspberry Pi, the MC 1.2 Plus or both. By simply comparing the sound quality between the MC 1.2 Plus in or out the chain, it becomes clear where the problem originates from. Using the internal power supply, the difference between having the MC 1.2 Plus in the chain or not is rather small. There's a small reduction of the stereo image and sibilance is a tad less. Keep in mind the test setup is of rather high quality. Using the Ferrum Hipsus external power supply took away those little differences. It speaks for itself that when your DAC has a proper USB audio class 2 input, you don't need the MC 1.2 Plus. But if your DAC has no USB audio class 2 input, or if your DAC only has a USB input while your source has not, the MC 1.2 Plus is a good solution for €762, which is reasonable money. And on that bombshell we come to the end of this video. There will be a new video next week, so subscribe to my channel or follow me on Patreon, Facebook, LinkedIn or Instagram to stay informed when new videos are out. Help me reach even more people by giving this video a thumbs up or link to this video on the social media. It is much appreciated. Many thanks to those viewers that support this channel financially. It keeps me independent and lets me improve the channel further. If that makes you feel like supporting my work too, the links are in the comments below this video on YouTube. I am Hans Beekhuizen, thank you for watching and see you next week. And whatever you do, enjoy the music.